So what we had derived earlier on, or reminded ourselves of earlier on, were the two conditions for the consumption sector and the production sector. But then we said that was only for one consumer. What we're now going to try and do is to put two consumers together, okay? And they're consuming two goods. That is why it is called the 2 by 2 XXX, sector. So you can have two producers, two inputs, two outputs, two consumers in this whole economy. That's why it's called the 2 by 2 economy model. In any case, let's try and derive the one side, the consumption side, which is also the exchange side for the two consumers. The two things that you need to remember is that is the condition of Pareto efficiency, that when none of the consumers can be made worse off, okay? When none of the consumers can be made worse off by trade, then you can still improve, okay, the situation in your economy, okay? So if one of them, for instance, could be improved, and then one of them remains at the same level of utility, okay, then you must still try and find room for trade to improve efficiency. But when you get to a point where if you try to change the allocation of resources, in this case of the two goods, and found that one of the consumers was made worse off, well, then you cannot improve the market anymore. Any movement there would be inefficient, Pareto inefficient. So the essence of this model really is about the virtues of trade. Trade is a virtue. Trade enhances efficiency. Okay? That's where we derive our conditions. So our conditions come from the fact that we have reached a level where you cannot improve efficiency in the system. Okay? It's equilibrium, general equilibrium model. In any case, what we did last time was indicate to us the indifference curves for one consumer. We can use the same graph, but instead of having one consumer, have two consumers. And these consumers would be competing with each other for the same quantity of goods, for the same units of goods. That's why the model that we uses an Edgeworth box model, and this is a box to represent that the goods are finite. Okay? So we have a box. So the axis that used to be for our first consumer remain the same axis, but we add another consumer. Say, for instance, Karen could be added there. And on the original axis, you could have, say, James. And we're saying that these two consumers have limited resources. So if this was good Y and that was resource X, when James consumes more of X, there's less available for Karen. And when James consumes more of Y, there's less available for Karen. So they are consuming the same resources, and these are finite. And that's what the box really represents. Okay, as well as the fact that now we have two consumers and, we're trying to represent them at the same time. So initially what we had were the indifference curves for James, right? So you could have some indifference curve map that would go somewhere there. Okay, let me use a different color for our consumer Karen. Because Karen's axis from the other way around would then have indifference curves sort of coming from this direction. Try and draw them smoothly so that they touch. Okay, well, they don't have to touch, but try and have points where they touch. But really the point is that at that point, Karen is consuming nothing. When you move inward into the box, Karen's share of resources, allocation of resources increases. So when you move from that direction to this direction, Karen's share in the economy is big, it grows. When you move to that direction, James' share in the economy also grows. But because they're competing, they can't grow at the same time. The other one is going to grow at the expense of the other one. All right? So what I said earlier when I started was that this model really tries to tell us about the virtues of trade, why trade is good, and why trade would achieve a better level of efficiency in the economy. So imagine that your two consumers were to start off at a point, say, A. Imagine that was the initial allocation of resources. At point A, James would be consuming a lot of Y, right? But Karen would be consuming just a little bit of Y, okay? So this is how the Y resource is shared between the two. At point A, James would be consuming that much X, and what is left is consumed by Karen. Now, if these two guys decided, well, you know, we could achieve a higher level of utility if we traded, if we bargained and traded the units of these goods, you will see that if that was their decision and they came together, in fact, that would happen and that would improve utility. So that would be Pareto efficiency enhancing. And that would come about because they came together, they bargained, and they traded. So say they started off there at point A, and they traded to some point B. Or they could have started at this point and traded and ended at, say, a point D. All right? What do we notice about this process? This is like a barter system, really, where two consumers come together. There's no price. They just come together and negotiate. And the condition is that none of them should be made worse off, meaning that none of them should have their utility being reduced. Okay? Starting off at point A, we see that James is on this indifference curve, right? When they negotiate and move to a point like B, we see that James would have moved from this indifference curve to a higher level of utility. So his utility has been improved. But when we start off at this point and say we move to a point D, we see that James remained at the same level of utility. But what happens to Karen? Karen was on this indifference curve. And then when we move from point A to point D, she moves from this indifference curve to a higher level of utility. So either way, whether they move from A to B or they move from A to D, the utility, one of the consumer's utility has been improved, the other one remains the same. And that's because of the virtues of trade. So trade has been useful in this economy. So a point like D, a point like B, a point like, say, C, a point like, say, E, where the indifference curves of these consumers touch are efficient points. And we draw these points, okay, we can draw them up, join them up, and have a line, okay? And we call this line the contract curve, meaning that along this line, any point along this line represents a situation where you've got Pareto efficiency in your model. Okay, so the marginal rate of substitution, okay, I can write it down. The marginal rate of substituting X and Y for James equals the marginal rate of substitution between X and Y for Karen. So this is the sort of like the initial step that we are developing in finding the equilibrium condition for the exchange sector. So what we're going to do next is look at what happens when you've got a price system, when your market has got prices given. So it's not like this economy, which could be an economy like India, where people get together and bargain and negotiate, and it could happen that one of the consumers is made better off and the other one is remain at the same level, okay, or it's the other way around. When you've got a price system, they don't get together and negotiate. They don't need to do that. The price will determine what the real price of the resources are.